All right, well, welcome back. So in the last section, we were actually introduced to the wonderful world of deterministic finite automata and how these notions actually lead into the world of regular languages. That is one of these languages that are going to be recognized by one of these crazy little machines. So before diving into the full world of regular languages and regular expressions, we're actually going to take a quick detour into what is going to be referred to as non-deterministic finite automata, which at this point in time, you're going to see that these two paths are essentially going to split just a little bit. But at the very end of this section, we're going to see that these two notions are actually going to be describing the same thing. So in the deterministic setting, what's going to happen is that you have these little machines that are going to go from state to state with a very set amount of rules, in that you're going to go from this initial state S0 into state 1 only if you're going to have one of these input characters be a 1. And then after that, you're going to go somewhere else, and then somewhere else, and then somewhere else, ultimately hoping to land at one of these final states. What's going to happen in the non-deterministic setting is that you're going to begin to see a bunch of these little paths start to split apart. What's going to actually happen in the little images is you're going to have some of these particular states that are going to have multiple arrows out of them, in that you're going to have a 0 into one direction and a 0 going somewhere else. So what's going to happen is that as you begin to parse through these things, you're going to see all kinds of little tentacles kind of emerge throughout this whole thing. If any of those little paths end up at one of these final states, we're then going to say that this particular machine is actually going to accept that particular string. So one of the ways to think about this world of non-deterministic processes is going to be viewing this as some type of parallel computation where there's actually going to be multiple independent processes or threads that are all going to be running concurrently. Another way you can actually think about this world of non-deterministic computation is actually going to be as some giant massive tree of possibilities. So the root, or the starting place, is going to then correspond to the start of the computation, and then every branching point in this tree is actually going to correspond to one of these points in the computation at which the machine is actually going to have multiple choices. So it's going to be one of these little scenarios where you're going to have 2 0 arrows that are going to be leaving from a particular state. Okay, so let's go ahead and jump into one of these crazy little examples to see all of this process come into play. So what I have is going to have one of these nice little non-deterministic finite automatas. So we have this nice little machine. There happens to be 5 overall states, and the starting place is going to be over here at S0. Right off the bat, you can actually see that this is going to be non-deterministic because S0 has 2 little 0 arrows that are going to be leaving it. So right off the bat, you know that this thing is not going to be your classic deterministic setting, in that something funky is going to actually be happening. You can see that something funky is only going to really happen if you begin to have some inputs that are going to have some zeros. If you start off with a few strings that are only going to be made out of 1s, nothing crazy actually happens. So if you give me the input string of just a 1, 1, you can see that you start at S0, you go to S1, you come to S4, and hooray, you end up at one of these final states. So that's going to say that this particular little machine, which we could call it an M, is going to actually accept that particular input of 1, 1. Whereas if you look at the input string of 1, 1, 1, you're going to go from here down to here and then up to S3, and that's going to be ending in a non-final state. So this little machine is actually then going to reject that particular input. One of the things to notice about this little object is that from this little state S3, there's not actually a 1 that's going to be leaving this thing. So it again has some kind of funny things that are going to be happening. So if we ever end up in that scenario that we get to S3 and we have another 1 that we're going to need to do, we know immediately that this machine is then going to reject that because it doesn't even know what to do with that particular thing. So often we're going to be sending that little thing off to just some dead state where it's never going to emerge from. It's going to be stuck there, never going to actually loop back into anything that's actually going to be useful. Okay, so those two were fairly standard in that they just had these kind of classic little just change. There were no decisions that actually ended up happening. You can start to see that some of the decisions are going to emerge right off the bat if we have the initial character actually being a 0. At that point in time, we have a choice. Do we sit at S0 or do we go down to S2? And then we keep on going from there. So let's go ahead and see how that's actually going to pan out with, let's say, the little input string of 0, 1, 1. So if we're sitting at this little node of S naught, and you give me a 0 as the very first character in this string, that it's going to initially start off this process of a split. So I can either sit here and not leave S naught, or I can jump down to S2. So what's going to happen is that I begin to make this little tree. And that was one of the ways that I like to think about this non-deterministic computation, is that I'm going to have this little tree that's going to then split into a whole bunch of random little possibilities. Again, it's this notion that there are multiple independent processes or threads that are going to be going on. So here we only have two, in that we're going to have that initial split, and then once we have a bunch of ones, we're going to be essentially in a deterministic setting, in that I have no other choices to be made. So S naught either is going to split down to S naught, or it's going to jump to S2, and then I'm just going to have to do whatever is going to be left. So if I go into the S naught one first, so here's where I don't leave, so I start there, I'm then at S naught, so I've used up the 0. Then I'm going to run this path up to S1, then I'm going to run this path down to S4, and you can see that that puts me into a final state. Whereas if I take the other path, what's going to happen is that I'm going to run down here to S2, I'm going to run over to a 1, and then I'm going to jump up here to S3, which is actually a non-final state. So the key in all of this is that once you make this giant little tree, if at least one of these nice little end nodes, these little leaves that are going to emerge in this tree, are actually ending in a final state, we're then going to say that this little machine is going to accept this input. So that's a key fact, is that we don't need every single little final thing to actually be in one of the final states. We need just at least one of them. Essentially, think about it as that there is some path that's going to go from this starting place into one of the final states using just these zeros and ones that this particular string is made out of. And that's actually an important aspect, is that it gives us essentially a look ahead option, in that I don't know right off the bat which path I should actually take. So I make every available path at my disposal, and then I choose the one that happens to work. If none of those actually work, then I know that this thing is going to be rejected. Okay, so let's look at another example, and I think I got a couple others just to kind of get our wheels turning into this process. So if you give me the input string of 0, 0, 1, 1, so again, we're starting over here at S naught, you're going to see that I'm going to have a few initial splits, and then once I hit the ones in this string, I'm just going to go crazy with it. So I'm going to have the initial split, which is going to say that S naught can either stay put, or it can go to S2. So that's essentially after that first 0 in my string. After that, well, the one that's gone and not left, so if I'm sitting at S0, that one's then going to split on the second 0. Whereas you can see that actually going down the path towards S2, I'm stuck there, in that there's no way to leave S2 on a 0. So that little branch is essentially just going to die off. That tells me that that's not the way that I should go if I'm actually trying to identify getting to one of these final states. So I'm going to initially make that split, and then you can see that I'm going to essentially throw it away and not care about it afterwards. Okay, so now I've had these first two zeros already accounted for. So I got the first 0, that one, and then I got the second 0 being that guy. And then I'm just going to have to do whatever the ones are going to tell me. I have no choice in what's happening with these ones. So if I'm sitting at S naught, and then I sat at S naught, so for the first two moves, I never left. Then what's going to happen is I'm going to jump up to S1 and then to S4, putting me into a final state. So right off the bat, you can actually see that this little machine is actually going to accept this particular input. But just for the sake of completeness, let's see what happens in the other direction. So if we do the S naught, so sit the first time, so one time there, and then go down here, and then go over there, and then go up there, you can see that I end up at S3, which is not a final state. So if that was the only little leaf that I saw in this tree, I would say that this little string would be rejected. But because this one actually worked, I know that it is in fact going to be accepted. I think I got, nope, that's it, I guess. In the next video, I'm going to show you a few of the languages, or the actual language that's going to be recognized here. But gives you kind of a feel for how these paths are originally started.